Now, hello, good morning. Coming to this question. The question asked is the most commonly used relay for the protection of alternator against loss of excitation. Loss of excitation is right. So, this was also asked in GATE 2022. He is asking which relay is commonly used for the protection of alternator against loss of excitation, right? Now, there is a key term called loss of excitation, right? What happens if excitation is lost for an alternator? It will run asynchronously. First and foremost point is it starts running asynchronously. That is, it behaves like an induction generator. Induction generator, right? So, what happens because of running asynchronously? What happens is then relative speed or relative motion between, let me write the point, relative motion between stator field and rotor field, generally it should be zero ideally, but here, since they are running asynchronously, relative motion between stator field and rotor field increases. As a result, they start inducing certain currents in rotor. So, because of whenever currents are induced, what happens? Temperature increases. Temperature of rotor increases. Right. So, in order to prevent all this, also we can add one more point, that is whenever it starts behaving like an induction generator, it draws reactive power. Right, let me write the point. Whenever it starts acting like an induction generator, it starts drawing reactive power. From where? From the grid. That's it. From the grid. And what happens? It operates at what power factor? What power factor? It is drawing the reactive power. It is drawing the reactive power, right? So simply it operates at leading power factor. Because of losing of excitation, all these things are happening. So generally among all the options given, offset more relay. This offset more relay will have RH characteristics in between fourth quadrant and third quadrant like this. Generally it will be having like this. And whenever this excitation is lost suddenly, what happens is when excitation is lost below a particular level, then offset more relay will come into action. What happens is that typical characteristics of alternator during loss of excitation will be shifted here. Offset more relay will have characteristics here. Let me write. Characteristic. And typical characteristic during loss of excitation. Right. So whenever the excitation is lost below a particular level, then this offset more relay will come into action, right? So the impedance of this induction generator will start shifting to the characteristics of this offset more relay, right? I mean, we can use a word called swinging. This induction generator will have certain impedance. That impedance will be swings into this offset more relay, and then relay will operate. This is what happens actually. And if you want, we can also add this characteristic also. In RX characteristic, we can add, this is the system fault characteristic, right? So if we want, we can also add the circuit, that is relay connection for loss of excitation of alternator. I will draw this also for your information. Circuit breaker. So this is more relay, right? This is how it is connected to the alternator whenever excitation is lost suddenly. So what happens when excitation is lost suddenly means it will run asynchronously. Synchronous motor, that is synchronous generator, that is alternator, will run asynchronously. That is indirectly it behaves like an induction generator. So whenever induction generator action comes, it starts drawing more and more reactive power from the grid, and it behaves like if it is acting like a leading power factor, right? Then what happens again? What happens is also the other consequence is the relative motion. Ideally, whenever it is running as an alternator, the relative motion between stator field and rotor field should be zero. Then only ideal torque will be produced. But here, relative motion between stator field and rotor field will start. I mean, it is not zero, and it starts inducing certain currents. So because of this currents, rotor gets heated, right? Rotor gets heated, and it leads to damage of bearings, etc., etc. It will be happening, right? Now, in order to avoid this, we generally go for offset more relay. Offset more relay, right? What this offset more relay does is, this offset more relay will protect the alternator from loss of, against the loss of excitation, right? If excitation is lost, all these are effects, and in order to avoid all these effects, we prefer offset more relay. So initially when it enters into the induction generator zone, initially it should be here. Initially the characteristic will be, alternator characteristic will be somewhere here. Whenever it started working as an induction generator, the characteristic will be shifted to here where the more relay is working, right? In this way it starts protecting. Whenever it shifts here, then offset more relay starts operating. And this is the typical circuit, typical relay connection for loss of excitation, right? Hope the concept is clear. I'll meet you with the next concept very soon. Thank you.